Hello, welcome to another tutorial in the blockchain developer series with Silas Auger. So there are a lot of terminologies surrounding blockchain development or blockchain tech, right? Sometimes something as common as what is a blockchain can get us quite confused or can be quite confusing. Okay, so before we talk about blockchain technology, let us understand what distributed systems are. So let's imagine you have lots of friends and you all need to work together on, let's say, a very big project. They each have their own tasks to do, right? So, which means everybody in your team is independent. One of your friends can decide to run away, another one can decide to actually do the job or the task. The other one might decide not to assist you, but it's part of the team. Okay, so they are together, right? But they share information, right, and help each other. So that's just what a distributed system is. So many computers working together like a team. Okay, so let me use a diagram and show you what I'm trying to explain. So these are several computers here. So one computer can be responsible for database, another one can be responsible for front end, another one can be responsible for another database, and so on and so forth. So several computers working together to achieve a task or a goal or an objective. Okay, so this is just what distributed system is or it entails. You can have several systems existing in a distributed pattern, but that doesn't necessarily mean that they are or it's a blockchain. Okay, so what then is a blockchain? All right, so there are different terminologies here. You look at stuff like digital ledger, linked blocks, transparency, and all of that. So let's use another analysis. So think of yourself being in a classroom, okay, and you have a special notebook where everyone in your class shares. So that simply means when somebody wants to borrow a book from that classroom, you write it. Somebody makes noise in that classroom, you write it. One of your colleagues is not feeling well, you write it. So everyone can see it and no one can change what's been written. In that context, that's how a blockchain basically works. So it's a digital notebook, sort of, where lots of people can write things down securely and everyone can trust what's written in it. So let me show you another diagram to explain or to illustrate what we're trying to explain. So, so look at this notebook now. This is like a page. So this page, you could write John Andrew, Paul Philip, Sarah Jibril. You can write, okay, someone, let's say, borrows. I'm looking at my keyboard. So borrows a notebook, stuff like that in one page. So in this notebook now, let's consider one page to be a block. Page 1 is a block. Page 2 is a block. Page 3 is a block. So now you can see that we'll have several pages. So these several pages are termed blocks. And the connection of all these blocks together, working as one, is what we call blockchain. Several blocks interlinked together. Now, you can also see the blockchain as a system of storage where data is not in one spot, right? So several blocks. Okay, so let's look at this. So block 1, block 2, block 3, block 4, block 5, and so on and so forth. All these makes up the blockchain. It's also worthy to note that for this block to relate with this block, there's something called a hash. I'm going to explain this later on, or better still, I'll allow you read on it so that I don't give you several explanations at this point to get you confused. But one thing I want you to understand is a page in this notebook we're talking about is considered a block. Page 2 in this same notebook is considered another block. So understand this concept and it will allow us or give us an opportunity to, fully understand what the blockchain entails. Okay. So now that we have an idea what a blockchain is, let's move to the next concept here, a node. So now let's also say in your classroom, let's still use the classroom analogy. In your classroom, each student is seen as a node or is like a node, right? They all have their own copy of this special notebook, right? This special notebook can be seen as the blockchain, okay? And each student can add new things to it or check what's already there. Let's look at a diagram to help us understand this better. Okay, so now this is a student. So each student has a copy of the notebook. So now this notebook has a complete copy of the blockchain. Another student has the notebook, which has a complete copy of the blockchain. So in this previous analysis we did, so take note, this is the notebook, a special notebook in the classroom. Paul, let's say Paul, let me do something here. This guy has this notebook. Oops, sorry about that. This guy has a copy of this notebook. And this guy also has a copy of this notebook, which is the same thing we just did here, right? So each student has a copy of the notebook, and the notebook, remember, in this notebook there are several pages which we refer to as block. A collection of those pages is what we refer to as a blockchain. Okay, now as a distributed system, this computer has the blockchain. This one has the blockchain. This one has the blockchain. So now this computer now is like a student. So let's also say this is the student, and the student is the node. Okay, so let's put a full stop there. So this is a student. This computer is it's like the student, using the student analogy. This is a student, this is a node. This is another computer, which is also the student and the node. So let's do this. Okay, so this has the complete copy of this blockchain. So every data here is reflected here. The same data you find here is also contained here. The same data you have here is also contained here. It's also contained here and here. So this is a decentralized, special kind of decentralized storage. But take note of very key things here that makes this a blockchain. Remember, this was the same analysis we used to explain distributed systems. So now we're explaining it, or using the same analogy to explain what the blockchain entails. Okay, so the copy of the ledger here, this guy has it. The copy of the ledger, this guy has it. So you can also see this now as a storage system where no central student has full control of the data. Paul is a student. He has the database. But Paul does not have full control of the database. Michael is a student. He has the database, but doesn't have full control of the database. So, key takeaway from here is this: data is not stored in a central location, but it's distributed across multiple nodes, right? Okay, so consensus. I'm going to explain this. Let's go back to the slide so that we can, follow the perspective. So we'll come back to this a little bit. Okay, so now that we've explained a node, let's move to the next thing: cryptography. You may come across the word cryptography, but what does it mean? Okay, so let's still use the student analysis. So imagine you have a secret code language, right? Out of 3, 4 students in the class, you have a special way of communicating with yourself, like a secret code, right? That only you and your friends understand. So you use it to send messages that only you can read. Any other person who sees it doesn't really understand what it means. So cryptography is like that secret code language, right? It's a way to keep information safe and private when it's sent over the internet. So that's just what cryptography entails, so that we don't bamboozle ourselves with all the grammar. Okay, so the next thing we'll look at, excuse me, is consensus algorithm. So, what is consensus algorithm? Let's still look at the class or the student case study. So when your class needs to decide on something together, yeah, maybe you want to take a decision like where to travel to, where to go for a picnic, the kind of teachers that shouldn't teach you again, shouldn't lecture you, stuff like that, right? Like, so you might need to vote to see what is appropriate. Okay, so in a blockchain system, a consensus algorithm is like the voting process that helps all the nodes, right? Students, in quote, all the nodes or the students to agree on what should be written in the special notebook. So let's explain this. Remember, there's data here, there's data here, there's data here. For us to decide on what to write here that should be reflected here, we have to come to an agreement, a consensus. So we have to do a voting system. So that is what we mean by consensus algorithm. So what enables or what ensures that data across all the chains are in sync is determined by consensus algorithm. Let me not explain too much so that we don't get confused. Okay. The next thing you might come across is immutability. So now imagine you wrote something in that your special notebook or on a piece of paper, right? Once it's written, it's written. You can't erase it or you change it without leaving a mark on it. So immutability in blockchain simply means that once something is written down or added to the blockchain, as the case may be, it can't be changed or deleted. That's just simply what immutability entails. Blockchain use cases. So one cool way to use blockchain is for keeping track of who owns what, like of course digital money, cryptocurrencies. It helps us also make sure that everyone agrees on who has what's needed, or without having a boss, somebody to lord it over you that it has to be this way. Not to talk of medicine, not to talk of supply chain, not to talk of agriculture, not to talk of a lot of other interesting places where blockchain can be utilized. But so far, we hear so much of blockchain in regards to cryptocurrency. Okay, so benefits of studying blockchain in today's era or in 2024. You look at career opportunities. There are several career opportunities out there. if you have a knowledge of blockchain. You could be a lawyer and you still major in blockchain. You can study. There are aspects of law you can utilize, innovation, security. We talk about stuff like decentralized identity management. Identity theft is something which blockchain easily solves with self-sovereign identities. All right, so a lot of other interesting benefits which we cannot exhaust all of them in this tutorial. So, conclusion: the transformative technology, wide-ranging impact, continued evolution. Feel free to research more about what you can gain as a blockchain engineer, as a blockchain architect, or as a blockchain lawyer, as a blockchain scientist, a blockchain agriculturalist, a blockchain journalist, so a lot of other interesting stuff. Feel free to drop any questions you may have, or if you want to throw more light as to what I've explained, you didn't get it right, feel free to reach out, drop a comment, and if I don't attend to you, one of our team members will definitely be in touch. Thank you and see you in the next tutorial. Bye for now.